This problem, we have a baseball player who is running at 4.5 meters per second, slides into second base over a distance of 1.75 meters. We're asked to find what is the coefficient of kinetic friction between the baseball player and the ground. So we start out, we draw our free body diagram. We have the gravitational force as always. We are on a surface, so there is a normal force upward. And there is friction. Now, if the baseball player is moving to the right, the friction will be to the left, and it is kinetic friction because he is sliding on the surface. There is no string, rope, or cable, so there's no tension. And there's no applied force. The reason that the baseball player is moving to the right is because of inertia, not because there is any kind of force acting in that direction anymore. We write down our givens, and we are given that the initial velocity is 4.5 meters per second. And we are given that he comes to a stop, so the final velocity is 0. And he moves over a distance, so delta x is 1.75 meters. We want to find what is that coefficient of kinetic friction. In all of our problems before, we were given the mass. And the first step was to always calculate what is the gravitational force based off the mass. But we're not given the mass this time. But we'll still write down that formula. So we'll proceed as if we had the mass. And if I had the mass, I'd multiply it by gravitational field, which is 9.81 newtons per kilogram, to get that gravitational force. So once I would have had that, I would then go to my two equations, in that the total force in the x direction and the total force in the y direction. Now in the y direction, they balance out. Baseball player is not moving up and down, and so that's 0. However, the baseball player accelerates in the x direction. So instead of balancing out, according to the second law of motion, when the forces are unbalanced, the total in that direction is mass times the acceleration. Now in the x direction, we have one force, and it is friction. The way that I drew this, it was to the left, so it would be negative. And that's equal to the mass times the acceleration. In the y direction, we have two forces. We have the normal force, which is up, and the gravitational force, which is down, and that's equal to 0. So this means that my normal force is the same as my gravitational force. They balance out. I don't know my gravitational force, so I'll just replace it with the other side of that equation, m times g. So if I did know the mass, I would know the normal force. Now at this point, we go to what we're really trying to find here, which is the coefficient of kinetic friction. And the only equation with the coefficient of kinetic friction is that the friction is the coefficient that we're trying to find times the normal force. Now if I had the mass, everything would work out fine. I would know the normal force, which is m times g. And my kinetic friction is equal to the opposite of the mass times the acceleration. Move the negative to the other side. What we notice though is that in this equation, the masses actually cancel out. So it doesn't matter what the mass is, the coefficient would have been the same number. So whether or not we're talking about a large or a small baseball player, it still would be the same value for the coefficient. That makes sense, because the coefficient of kinetic friction is really a number that's telling us the roughness of the surfaces. Has no basis on how heavy the surfaces are going to be. The only problem is we need to know this acceleration. And that's when we go back here, and we're going to use these three values to get our acceleration. So this is back from the very beginning of the year with kinematics. So Vf squared is Vi squared plus 2a delta x. That's the equation we're going to use. I know Vf is 0. I know Vi is 4.5. And I know delta x is 1.75. So now I can come in and solve for the acceleration, and I get negative 5.79. And I can go back to my formula now and see that we have the opposite of negative 5.79 meters per second squared is equal to our unknown, our coefficient, times 9.81 newtons per kilogram. Now remember that a newton per kilogram is equivalent to meters per second squared, because a newton is an abbreviation, I'll just write this to the side, a newton is an abbreviation of a kilogram times meter per second squared. So if we divide by the kilogram, it's just the same thing as a meter per second squared. So our units here for coefficients still come out to be unitless. And we get that coefficient to be 0.59. So to recap, if we are not given the mass, we just proceed the same way, but we're dealing with letters here instead of numbers.